So let's begin with unit number 4. In unit number 4, we are going to discuss about the data storage and the concept of indexing. So in our earlier discussions, in our preceding units, we have emphasized the higher level models of database. For example, we discussed about the conceptual or logical level of database. We viewed the database in relational model. We tried to write the queries, right? In fact, the logical model or the conceptual model or the relational model that we have studied or gone through is the correct level for database users to focus on. Because goal of a database system is to simplify and facilitate access to data. And users of the system should not be burdened unnecessarily with the physical details of the implementation of the system. However, being computer professional, even though we are knowing these higher level models and the higher level operations, the SQL and all, we should know the underlying details as well, right? And that is why from this unit onwards, we are going to discuss the concepts, those are there underlying our database system, right? So in this unit, we are actually going to focus upon how the data is being stored, how the records are stored, how the files are organized in our database system, what kinds of data structures are being used, which are best suited for a particular kind of access to the data, and so on. Also, we will be focusing upon how to expedite accessing the data from the database. So we'll also be focusing upon indexing. So indexing is meant for searching the data or extracting the data from the database system efficiently. And data storage part of this unit will focus upon how actually the records are being stored into the files, which kinds of data structures are being used, what kinds of file organization methods are there. So we'll be focusing upon all those details in this unit. So most of these units from this unit number 4 onwards, those are the theoretical one. So what we are going to study in this unit, we'll be focusing upon file organization, organization of records in file, data dictionary, database buffer. Then we'll be focusing upon basic concepts of indexing and hashing. We'll see ordered indices, multi-level indices, B plus tree indices. So these are various methods of indexing. Multiple key access, static hashing, dynamic hashing, bitmap index, and how index is being implemented in structured query language, right? So these are the contents, those we are going to discuss in this unit, right? So which textbook we are going to use? So database system concepts. This is the textbook that we are going to use for this particular unit, right? So I hope now you must have understood what we are going to learn in this unit and which is the resource that we are referring to. Now, let's begin with the concept of file organization. A database is actually mapped into different files. Those are maintained by the underlying operating system, right? So these files actually reside permanently on disks, right? Now, if we look at a file, file is organized logically as a sequence of records. So in database system, what we have, we are having a table or a relation wherein we are having several records, right? So file is organized logically as the sequence of records in the database, right? Now, these records are actually mapped onto the disk blocks. So basically, files are provided as a basic construct in operating system, right? And disks are divided into disk blocks. And every file is assigned several disk blocks depending on the data that we are storing into the file. So obviously, as we are storing records in a file, these records are being mapped onto the disk blocks. So a storage device or a disk is partitioned into disk blocks, and the records, those we are going to store, are mapped onto the disk blocks. Right? Are you getting me?
Yes, ma'am.
Fine. So each file is partitioned into fixed length storage or storage unit that is called as the block, right? And the records are being stored onto the blocks. So although blocks are of fixed size determined by the physical properties of the disk and also by the operating system, records, those we are storing in these blocks, vary in size. I repeat, blocks are of fixed size, right? Typically, the block sizes are 4 to 8 kilobytes, right? Some database systems may allow block size that is being specified when database instance is created. But whenever we are talking about the basic building blocks, those are provided by operating systems. Typically, most databases use the block sizes of 4 to 8 kilobytes. Right? So block sizes, those are being used by databases, are typically of sizes 4 to 8 kilobytes. Right? So these block sizes are fixed depending upon the physical properties of the disk and the operating system. But the record that we are storing onto those blocks may vary depending upon what data and what type of data we are storing in the form of records. Right? Are you getting me? Yes?
Yes, ma'am.
Fine.
Yes, ma'am.
So we need to consider now the ways of representing these logical data models in terms of files. Right? So in relational database, the tuples of distinct relations are generally of different sizes. Right? What I mean by this, let us see some examples. Suppose I am having the instructor relation. So in my instructor relation, I'll be storing some records. And in that record, I'll be having the values associated with the attributes of that relation. Right? In some other relation, I'm storing some other kind of data. So depending upon the attributes and types of attributes, whatever data I'm storing is different. So it may happen that the record size of my instructor relation is different from the record size of my department relation. Right? So one approach to mapping the database to the files is to use several files and to store records of only one fixed length in any given file. An alternative is to structure our files so that we can accommodate multiple length records in a single file. However, the files of fixed length records are easier to implement than the files of variable length records. Right? So there are several techniques. Those are being used to store either fixed length records or variable length records. And now we are going to discuss such kinds of methods. Those are being used to store fixed length records in the file or variable length records in the file. So to begin with, we are going to discuss now how to store fixed length records. Right? Now, let us consider that we are having the instructor relation. Right? And every tuple or every record in instructor relation is defined with 4 attributes. So ID is of type char and having the size 5. Name is of type char and having size 20. Department name is also of type char and with size 20. Salary is numeric type and the precision is 8,2. Right? So this is how we want to store our data in our instructor table. So record is specified in this manner of instructor table. So let us assume now that each character occupies 1 byte. Each character occupies 1 byte. Right? And the numeric data requires 8 bytes. Right? Every character requires 1 byte and the numeric data requires 8 bytes. So, if I want to store now one instructor record, then how many bytes are required to store one instructor record? How many bytes? Yes? Anybody? Yes. Is that so difficult? 50? 53 bytes. 53 bytes, correct. 53 bytes are required to store one instructor record. And this record is fixed length record, meaning to store each record, we will be requiring 53 bytes, irrespective of the size of the string that we are storing. Why? See here, whenever we are defining this instructor record, we are saying that ID is of type char. So char meaning to store this ID, we are allocating 5 bytes of memory. For name, we are allocating 20 bytes of memory irrespective of the actual size of the name. Actual characters, those are being stored in the name. So char type itself is the fixed length data type that we have seen earlier, right? We are not using here varchar, but instead we are using right now here char type, meaning it is the fixed length type. So if I am designating 20 bytes for name, then all those 20 bytes will be allocated to store name of the instructor, irrespective of the actual number of characters those I am storing as the name. Right? So 5 bytes are required for ID, 20 bytes are required for name, 20 bytes are required for department name, and for salary, which is numeric, 8 bytes are required. So total bytes required to store one instructor record is 53. So 53 bytes are required to store one instructor record. Right? Now, this simple approach to store these records is like first 53 bytes will be assigned to this 0th record. So our record index starts from 0. Okay. So this 0th record is stored in first 53 bytes. Then next 53 bytes are assigned to record number 1. Next 53 bytes are assigned to record number 2, and so on. So this is a simple approach that we may have to store the records of a particular relation. Right? Now, in general, we are going to store ith record starting from byte n into I, where n is the size of each record. Right? So, if I am storing this 0th record, then I'll be storing this record starting from this 0th byte. If I want to store this first record, then I value is 1. N number of bytes required are 53. So 53 into 1. So the first record will start from byte number 53. So 0 to 52 bytes are meant for first record. Then 53, from 53 onwards, next 53 bytes will be required to store record number 1, and so on. Right? So this is a simple approach to store the records one after another. Right? But if I follow such kind of approach, then I may come across some difficulties. So what are those difficulties? Even though accessing the record is very much simple in this kind of organization of records, the records may cross the blocks. What does this mean? Records may cross the blocks. What it means? See, we are having some fixed block size, and in that block we are going to store the records one after another. So unless the block size happens to be multiple of 53 in our case, unless the block size happens to be a multiple of 53. Some records will cross the block boundaries. That means part of the record will be stored in one block and part of the record will be stored in another block. So, if I want to read that record, I need to access two blocks. Or if I want to write that record, once again, I need to have two block accesses. So, two times I need to access the blocks. Are you getting me?
Ma'am, please repeat once again.
Okay, so what we are saying, how actually these records are being stored. We are having a disk. Disk is partitioned into blocks, right? Certain blocks are being allocated to the files. We are storing our records into the files, right? So ultimately, we are storing the records onto the blocks. Now, we are talking about fixed length records now. So if we follow the approach like this, one after another, we are storing the records. Okay, now let us assume, this is just the assumption, okay? So let us assume that our block size is, say for example, 200 bytes. Let us assume actually the block size is different. It is approximately 4 to 8 kilobytes. Okay, but right now for understanding the concept, let us assume that our block size is 200 bytes. Okay, so if I am having the record exactly of size 50 bytes, then no doubt 4 records can be accommodated in one block of 200 bytes. Do you agree with me?
Yes, ma'am.
Fine. But it is not the case. Our block size is not usually the multiple of the record size. In this case also, if my record size is 53, then what will happen? 3 records completely can be accommodated in my block of size 200 bytes. Correct? No? So 159 bytes are required for 3 records. Is that correct? Are you getting me?
Yes,
Yes?
ma'am.
So how many bytes are remained from the block if my block size is 200? 41 bytes, isn't it? So 41 bytes are remained after storing 3 records. So whenever I will store 4th record in the same block, what will happen? I'll require 53 bytes once again to store 4th record, right? But 41 bytes of this record will be stored in block number 1 and remaining 12 bytes will be stored in block number 2. Right? So one record is being stored in 2 blocks. So unless the block size happens to be the multiple of my record size, and which is very unlikely, some records will cross block boundaries. So some records are being stored on multiple blocks. So it may happen happen that one record is stored in more than one blocks. And if it happens that to read or write such kind of a record, I will require 2 block accesses. Right? So this is one problem associated with this fixed length records or this approach of storing the records having the fixed length. Right? Another difficulty of this scheme is observed while deleting the record. So if I want to delete a record from a table, then I may have several alternatives. So what are those alternatives? Suppose I want to delete this record number 2. So simply I'll be removing this record from my table. So removing this record meaning I'll be having now this empty space in between. So my 0th record is there, my first record is there, this is being deleted, so there is empty space, and then my 3rd record is there, and so on. Right? So if I do not want to have this empty space in between, then what I can do? One approach is to shift all the records from record number 3 onwards, one position up. Right? So every record needs to be moved from its old location to the new location. Correct? So if I'm doing such kind of effort to move all the records, right now we are having only 12 records, right? But in fact, in our relations, we are having thousands of records. And if I'm deleting one record and to maintain the list correctly, if I follow the approach that I'm shifting the records from their original location so that this empty space can be allocated, then the extra overhead is associated with this shifting of records. So this was the first approach. Move records I plus 1 to n to I to n minus 1. Right? So shifting all the records to the new position. Another approach that we may follow is if this space, record number 2, this space is empty, then what I can do is instead of moving all the records, what I can do is the last record can be shifted to this ith position. So move record number n to this ith position so that I can reduce the overhead. Right? I will not be shifting all the records, but only one record is being shifted to this position. So that is the alternative number 2 that I may have. The third alternative is do not move the records, but provide the links to all the free records and create a free list. So what does this mean? See here. We are having now one header associated with the table. Right? So what we are going to do is by making use of this file header, we are going to store address of the first empty record, first deleted record into this header. Right? So if I want to find out the deleted record, then this header will take me to this first record which is deleted. Right? Now, in this record, I'll be having the pointer that points to, sorry, I will be having the pointer that points to the next record that is deleted. Once again, in this deleted record, I will be having a pointer that will point to the next record that is deleted. So this is how we are having a linked list, which can be referred as free list. Right? So I will be getting a free list by making use of or by following these pointers. Right? And if I have deleted those many records from my database or my file, then if I am inserting a new record, then what I will do? I will refer to the header. I will find out if there is any deleted record. So this pointer will take me to this record. And if it happens that I want to insert a new record, then I will be inserting a new record at this place because I am maintaining the list of free records. Right? So this is the third way how we are going to address deletion of records if we are using such kind of approach to store the records in a sequential way, one after another. Right? So this is with respect to fixed length records, meaning we know that the record size of every record is same or fixed. Right? Then this kind of a technique can be used to store the records. Right? And we may have this kind of a free list to find out the records those are being deleted so that we can accommodate that space for other records. Right? So this is how actually the fixed length records are being stored and manipulated using such kinds of data structures. In the next class, we are going to focus upon variable length records. Right? And how these records are being stored onto the blocks. And what important points those we need to consider for organizing the records into the blocks if the record size is variable. Right? So I hope you must have understood the concepts those we discussed today regarding fixed length records and organizing those records into the blocks of files. Right? So let us conclude today's session. Thank you.